So here we go, let's look at another one.
I'm falling asleep now.
Oh, well, sorry. I didn't mean for it to be boring for you. So let's look at example 3. We got x squared times y double prime plus 2x times y prime minus 6y equals 0. And we know that one solution is y1 equals x squared. We need to find another solution. So here's one way of looking at this one. First, we rewrite this equation by dividing by x squared as y double prime plus 2 over x y prime minus 6 over x squared y equals 0, and then we get p of x equals 2 over x. And that means when we set up to find our y2, we're going to have x squared, our known solution, times e to the negative 2 over x dx divided by this x squared dx. So let's see what on earth this makes up. Of course, this is going to be x to the 4th down here. And this e to the negative 2 over x dx is e to the negative ln, actually e to the negative 2 times ln of x. But recall e to the ln of x is just x, so that's 1 over x squared, or x to the negative 2 if you will. So what we wind up with is x squared times, here's the x to the 4th. Here's what I was saying, this is really x to the negative 2, so that means we really have this as x to the negative 6, so it's x squared times the integral of x to the negative 6 dx. And of course, integrate that, add 1 to that power, you get x to the negative 5, divide by negative 5, and so we do get this result. Now, we don't care about the constant, make it be 0, and we can ignore this because it isn't going to affect the linearly independence of the two functions by multiplying one by a constant. So we got our fundamental set. If you multiply this out, it's really just x to the negative 3. So x squared times x to the negative 3, and the general solution to this homogeneous equation is y equals c1x squared plus c2 times x to the negative 3.
Oh, that's hard.
Well, that might be a bit hard, but let me show you an alternate path, and you probably like it better the first way. So, we start with our equation, as in method 1, dividing by x squared. And so, we assume a solution of the form y equals u times x squared. U is some function, by the way. I didn't want to keep typing u of x, so. And then we can differentiate and substitute. So differentiating this, first d second, here's that, because the derivative of x squared is 2x. So plus second d first, so x squared times u prime. And y double prime would be, okay, take the derivative of this, that would be u times 2x. So derivative 2 times derivative of x, so that's 2u, plus similar fashion, x times derivative of the first, so that's 2u prime, x. And then plus first d second, that's 2x u prime, and then second d first u double prime x squared. And simplifying all that, we come up with 2u plus 4u prime x plus u double prime x squared, right? That's from adding this one and this one together. Okay, now what? Well, here's that equation, but when we substitute for y double prime, instead of having y double prime, we're going to have this. So we'll put that in there for y double prime. We'll put this in there for y prime. See, there's a 2 over x times y prime. That's from the original equation. 2 over x times y prime. Here, see it? And then minus 6 over x squared times u times x squared. Remember, that's what we said. Let y equal u times x squared, and then try to find u. So, now that we've done that, this whole big ugly mess will simplify a whole lot. I confess that there's a 6u in there, that's just 2u, and see here the x's cancel, so plus this 4u, so we get 6u here. What else do we have? 6u prime x, see, that's from here, and this 2 times this one of these x's cancels this one, so that's plus 2 more, so we wind up with 6 u prime x, that's this 4 plus this 2, and then u double prime x squared, I think you can see where that comes from. That comes from here. And then minus 6u, because look, here the x squared here and here cancel out. And that's what's always going to happen. When you make that substitution, you're going to lose the term that appeared with no derivative. So then you're only going to have the term with the first and second derivative. And now if you let u be w be the first derivative and w prime be the second derivative, we've reduced the order to 1. So then it's 6w plus w prime x squared equals 0, and now dividing by wx squared, we got it separated. 6 over x plus w prime over w equals 0, or you could do it this way, 6 over x equals negative w over w prime. Integrating both sides, 6 times the ln of x equals ln of w. Actually, I should say plus c here. But the e to the constant you're going to get if you do that, it's just going to wind up being a constant, and remember that the constant does not affect the linearly independent nature of the solution. So you get x to the 6th equals 1 over w. That's, you know, e to the negative ln of w is e to the ln of w to the negative 1, which is 1 over w. So we got x to the 6th equals 1 over w, or w equals 1 over x to the 6th. That's another way of looking at it. So now we need u. And since w equals u prime, we can get u by integrating, right? Because we got w, here's w, that's u prime. One integration, integrate this, we get negative 1/5 x to the negative 5 plus c. But let c be 0, and then our y2 is x squared times negative 1/5 x to the negative 5. But we can use any multiple of this, so the negative 1/5 is irrelevant, so we're just going to use y2 as x to the negative 3, and the general solution is c1x squared plus c2 times x to the negative 3.
That was very satisfying.
I'm glad.